this chemistry class. So, we have completed our unit 3. What is our unit 3? Elements, compounds and mixtures. We have learned about what is an element, representation of element and its properties, then compounds, its representation, then mixture, what is a mixture, types of mixtures, then we have learned about separation techniques, finally paper chromatography. Like this we have completed our 3rd unit, and today's class we are going to revise about elements, compounds and mixtures. Only 3 topics we are going to revise today. The next remaining topic of this unit can be revised in the next class. First one is element. What is an element? Can you remember what is an element? Elements are pure substances that cannot be broken down into smaller pieces. Elements cannot be broken. It is the final stage of a matter. It cannot be further broken. It is a pure substance. Example for element: carbon, hydrogen, nitrogen, gold, silver, water. These are all elements. How the substances occur in pure form? Consider gold. The gold will have only gold atoms. So, gold is an element which has only atoms of gold. No other atoms or impurities will be present in this gold. So, it is called pure substances. Then, how many elements we have in the world? Yeah, very good. We have 118 elements, out of which 92 elements are natural and 26 elements are man-made. Whatever we see in this world, for example, chalk piece, blackboard, chair, table, food items, whatever we see in this world are called matter. All these matters are composed of only this 118 elements. Only this 118 elements combine in matter form to form everything around us. So, we have 118 elements, and out of which 92 elements are natural and 26 elements are man-made. Next is, we have 4 types of elements based upon their properties. This element, some elements can have same properties, some may have different properties. So, depending upon the properties of elements, there are 4 types of elements. They are metals, non-metals, metalloids. Last one is noble gas or inert gases. There are 4 types of elements: metals, non-metals, metalloids, noble gases or inert gases. Then the next one is representation of elements. How we represent these elements? How we are representing these elements? We represent elements using chemical symbols. Say some example for elements. Oxygen. How you will represent oxygen? O. How you will represent hydrogen? H. So, elements are represented using chemical symbols. These chemical symbols can have 1 letter or 2 letters. All the elements have chemical symbols. All these elements can have, some of the elements have single letter and some have 2 letters as symbols. For example, consider oxygen. Its symbol is O. It has 1 letter. Hydrogen. Its symbol is H. It has 1 letter. And carbon, it has 1 letter, that is C. Like this, elements with 1 letter. Then some elements have 2 letters. For example, helium, He, neon, Ne, chromium, Cr, chlorine, Cl. Like this, some elements have 2 letters. Well, while you write one letter, this one letter should be a capital letter. Oxygen should be denoted as capital O. And when you come to 2 letters, when you represent some elements using 2 letters, the first letter should be capital letter and the second letter should be small letter. Example, for chlorine, C should be capital and L should be small letter. And last, consider carbon, chromium, chlorine. These 3 elements have the first letter C, C, C. So, only one element we can give the same name. So, this carbon is represented as C, chromium as Cr and chlorine as Cl. So, when element is represented using chemical symbols, the first letter is used. When more than one element has same first letter, 2 letters can be used. Clear? Next one is compounds. What are compounds? These are also pure substances and these are the combination of elements. For example, consider water. Water has hydrogen and oxygen. Hydrogen is an element, oxygen is another element. These 2 elements combine in some atomic proportion. Consider this hydrogen has 2 hydrogen atom and 1 oxygen atom. This 2 hydrogen atom and 1 oxygen combines to form H2O. H2O is water molecule. Next, this is table salt. The salt we use in our home, it is 1 sodium atom and 1 chlorine atom combines to form salt. Glucose, carbon, hydrogen, oxygen in proportion 2, 12, 6. That is 2 atoms of carbon, 12 atoms of hydrogen and 6 atoms of oxygen combines to form glucose, that is sugar. So, compounds means one or more elements combines in some atomic proportion to form compounds. Representation of compounds. How we will represent elements? How we have represented elements? Elements we have represented using chemical symbols. Here compounds can be represented using chemical formula. Consider this as a compound. The chemical formula for sugar is or glucose is C2H12O6. The chemical formula for table salt is NaCl. The chemical formula for water is H2O. This H2O, NaCl and the C2H12O6 has some names. Elements has some names, right? H is hydrogen, its name. Like that, compounds also has some names. This can be called as water. This is sodium chloride. This is D-glucose. These are the chemical names. Generally, there is an organization called IUPAC. This is the organization which gives name for this chemical formulas. So, compounds are represented using chemical formula. This chemical formula has some chemical names. This IUPAC gives name for this chemical formulas. Next one is characteristics of compounds. So, there are 4 characteristics of compounds given in your text. They are, first one is, as we learned here, the chemical compounds. Their compounds are represented using chemical formulas. Next one is composition is fixed. Consider water molecule. It has 2 hydrogen atoms and 1 oxygen atom. Now from wherever you take the water, you are taking from pond, you are taking from well, you are taking from tap, from wherever you take the water, this composition will not vary. Water will be H2O. So the second one is composition is fixed. Understand? Next one is consider chemically new substances formed. You are having hydrogen separately and oxygen separately. Now you see the properties of this hydrogen and oxygen, and after you combine this hydrogen and oxygen as water molecule, and now you consider the properties. The properties before and after will be different. So, while you consider the hydrogen, the chemical properties of hydrogen atom and the chemical properties of water form, both will be different, entirely different. So, the chemical properties of the new substance formed will vary. That is, consider this NaCl as elements. Sodium is one element, Na is an element, chlorine is an element. While you consider this sodium and chlorine separately, this will have some chemical properties. And after combining, while you consider the chemical properties of this sodium chloride, it will vary. Did you understand that point? The last one is broken down chemically and it cannot be separated using any physical methods. Take a bowl of water. You are pouring off water in another bowl. What will happen? In the both bowls it will be H2O, H2O. We cannot separate this hydrogen and oxygen by physical means, but by some chemical methods. For example, water can be divided into hydrogen and oxygen by using electrolysis. Like this, by using some chemical methods, we can separate this compounds. Clear about compounds? Compounds, its representation and characteristics. Shall we move on to the next one? Next is mixtures. Elements and compounds are pure substances and mixtures are combination of two or more pure substances. That is, mixture can be formed by combining elements or compounds, but this combination is only physical combination. That is, the chemical properties will not change. The particles in the mixture, it is just physically combined and the chemical properties will not vary. Example, consider salt, sugar. While you mix the salt and sugar, what happens? The salt and sugar will be in the same bowl, but it will not combine chemically. Next one is sand and salt. You are taking some sand, salt. When you combine this both in a same bowl, what will happen? It will physically combine and it will be in one bowl, but the chemical composition will not vary. It is called a mixture. Any mixture you can say. Can you remember that we are combining this iron pieces and sand in a mixture and using magnet we separated? Yeah, like that. A mixture means the physically combination occurs and there is no change or there is no variation in its chemical properties or there is no chemical reaction happen in the process. Example, salt, sugar. It can be sand, salt, sand, sugar, anything. Then they have given some differences between compounds and mixtures. You have to go through the book for that. Now what is given there is the compounds, it is combining chemically, mixtures combining physically, compounds, two or more elements combine to form compounds, mixtures, elements, compounds combine together to form mixtures. Like that, they have given the difference between mixtures and compounds. You have to learn that. Then the next one is types of mixtures. Main two types of mixtures is homogeneous mixtures and heterogeneous mixtures. Before that, where they have given some combination, that is solid, solid. Example, both should be solid. Same example we can say, salt, sugar. Next one is solid, liquid. Solid, liquid mixture, what is the example? Consider water and you are adding salt in that. Salt is solid, water is liquid. So this is solid, liquid mixture. Next one is solid, gas. Example, smoke. The atmosphere, we can see some smoke, right? Sometimes small dust particles will be available in the air and it will be smoky in nature. So it is solid, gas. Example, smoke. Then liquid, liquid. Consider alcohol. In alcohol we add water. So alcohol is a liquid, water is a liquid. It's an example for liquid, liquid mixture. Next one is gas in liquid. Consider Fanta, Coca-Cola. While you open this bottles, gas comes out, right? That is carbon dioxide gas. So the bottle, solid gas is there, Coca-Cola liquid is there. So it is liquid gas mixture. Last one is gas in gas. Consider the normal atmospheric air, which contains many gases, nitrogen, oxygen, carbon, etc. So gas mixture. Example, air. So clear about this solid, 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 liquid, solid gas, liquid, liquid, gas, liquid and gas mixtures. Shall we move on to the next one? Next is homogeneous mixture and heterogeneous mixture. Homogeneous mixtures are uniform. Homogeneous mixtures, the particles are distributed uniformly and we can not see the particles after mixing and we cannot divide. Homogeneous mixtures can be studied using two headings, that is solution and alloys. Solution example, sugar solution. In sugar solution, when you dissolve this sugar in water, we cannot see that sugar again. So, solution contains two substances, that is solute and solvent. When you consider this sugar solution, sugar is a solute and water is a solvent. You have to put the solute in solvent and dissolve it. Next is alloys. Alloy is a mixture of metal plus metal or non-metal. One should be metal. With this metal you can add metals or non-metals. For example, gold. When you consider alloy of gold, it contains gold and copper. Next one is heterogeneous mixture. Heterogeneous mixtures are non-uniform. The distribution of particles in heterogeneous mixture is not uniform. We can see the particles inside that mixture and we can divide it. For example, consider the suspension. Heterogeneous mixtures can be studied with these two headings, that is suspension and emulsion. Suspension, what is suspension? Consider a beaker, you have water in that. You have to powder a chalk and put it inside the water. What happens? The chalk will float or suspend in the liquid. It will not dissolve. And when you keep this mixture for some time, the chalk powder will settle down in the bottom. So, as I said, heterogeneous mixtures are visible. The chalk powder inside the water is visible. Then divisible. While you allow this mixture, sometimes for settling down, the chalk powders will settle down. So it is divisible and non-uniform. While you put the chalk powder, the distribution of this chalk powder in the liquid is non-uniform. One place is two or more pieces will be there. One piece is only one piece will be there. Like this, distribution is not uniform. Then emulsion. Emulsion is a mixture of immiscible liquids. Immiscible means both should be a liquid but it should not mix. For example, water and oil are immiscible liquids. So emulsion has immiscible liquids and it can be separated. We have learned in separation methods, right? Using fractional distillation or separating funnel method, you can separate this liquid mixtures. So clear about what is elements, compounds and mixtures. So in the next class you will be having the test in this 3 headings. Prepare well for the test. Thank you.